Good morning, Miss Ian.
Good morning, class. I'm Miss Ian. Today, I'm going to show you a few examples of using different rules of differentiations to find derivatives. Many times, students are very confused when they see different equations. So today, I'm going to give you more ideas about this by showing you a few example equations, very similar equations. And first of all, let me show you the rules that I will be going through today. They are addition subtraction rule, chain rule, and also quotient rule. And as for chain rule, instead of using the product of two derivatives, I will be using the formula, which is times the power less by 1, and differentiate inside. But student, please remember that the product of two derivatives is still necessary when you are dealing with problems that involve more than two variables. For example, rate of change. You might have already learned the rate of change. If you have not learned yet, I think you are going to learn this soon. Okay, so next, let me show you the equations that I'll be finding derivatives today. So as you can see from these three equations, they look very similar and they all involve algebraic fractions. And if you compare the first and the second equations, the second equation is actually the reciprocal of the first equations, where the denominator 4 has become the numerator, and the numerator x squared minus 2x has become the denominator. And if you look at the third equations, comparing with the second, you can see that the numerator 4 has become 4x. Okay, so next let me show you. Okay, and most of the times when students see these equations, they would think of using quotient rule. But is quotient rule the only way? Is there other much easier way? Let's start with the first equations. Okay, in these equations, we have algebraic fractions where you can see a constant term as its denominator. So student, please remember that whenever you see only one term as its denominator, which means you don't see any addition and subtraction sign in the denominator. For example, for this, which means this denominator is one constant term. Like 4 or any other number, and it can also be one algebraic term like 4x, and so long you do not see any addition and subtractions as the denominator, we can always put these fractions into separate terms. So in this case, we can separate x squared and 2x as they have the same denominator. What am I going to do is, I'm going to put y equals to x squared over 4 minus 2x over 4. And this can be simplified as 1 over 4x squared minus 1 over 2x. Once we have this form, we can differentiate this equation term by term by using addition and subtraction rule. So what I mean is, for dy by dx will be equals to 1 over 4 times 2x minus 1 over 2. And then this can be simplified as 1 over 2x minus 1 over 2. Okay, how about quotient rule? Will quotient rule still work for this equation? Let's find out. Okay, let me put down quotient rule here. Okay, so in order to use quotient rule, we will need to let u be equals to x squared minus 2x and v equals to 4. So we will have du by dx, and by using the formula, we need to times the power to and power less by 1, so 2 minus 1 is 1, and minus, so everybody should know that differentiate a term in x, differentiate a term in x, we always copy the number 2. Number of x, we copy the number, and dv by dx is 0. Okay, let me scroll down a bit. Okay, by using the formula dy by dx equals to v du by dx minus v, sorry, it should be u, sorry about this, let me erase this, minus u dv by dx over v squared, and we just need to put all this thing in. We will have 4 2x minus 2 minus x squared minus 2x, dv dx is 0 over v squared is 4 squared. And everybody should know that whenever you multiply 0, the whole thing here will be 0. This whole thing here will be 0. So I'm going to expand the numerator and simplify this. There we have 8x minus 8 over 16. And if I separate this, we will have 8 over 16x minus 8 over 16, which gives us the same result as the earlier method. So, which method would you prefer to use? Do you prefer to use the first method or the second method? I would definitely go for the first one. First of all, it's less working. Second of all, you might be making mistakes when you use quotient rule. Let's start with the second equations. So in these equations, we can see there's additions and subtractions involved in the denominator. So can we do the same method like what we do for the first equations? Unfortunately, we can't. We can't put this into separate terms. So student, please remember that whenever you see addition and subtractions, addition or subtractions involved in the denominator, we can't put this into separate terms. So must we use quotient rule then? Is there any other easier way? Okay, let me show you this. Student, please remember that whenever you see a constant term, remember it must be a constant term with no other variable like x. We can put this, sorry, there's an a missing here. We can always put this into this form. Square minus 2x to the power of negative 1. By using this form, we can use the formula of chain rule to find the derivatives dy by dx instead of using quotient rule. So in this case, we will have dy by dx equals to 4 times the power negative 1 and power less by 1. So negative 1 less by 1 is negative 2. And don't forget to differentiate inside, which is 2x minus 2. So by simplifying this, we will have negative 4. I'm going to put 2x minus 2 times x squared minus 2x to the power negative 2. And for the power negative 2, we can actually put this as a denominator over x squared minus 2x to the power of 2. And for the numerator, you can expand, and we will have negative 8x plus 8 over x squared minus 2x to the power of 2. So by putting into this form, we will be able to use the formula of quotient rule instead of we will be able to use the formula of chain rule instead of using the quotient rule. What if we use quotient rule? You may try to find it out. You may try to do it and find it out. I'm sure you will get the same answer. Okay, next let's look at the last equations. So in these equations, we have algebraic fractions. Can we put this into separate terms? Unfortunately, we can't. I'm sure that everybody knows that we can't put into separate terms because there's a minus in the denominator. But can we put this into a form where we can do a formula of chain rule like the second equations? We can't because we have a term in x. A term in x. There's an x here. So we can't use the way that I showed you in the second equation, which is chain rule. So in this way, in these situations, quotient rule is the only way. So in order to use quotient rule, I will need to let u be equals to 4x and v equals to x squared minus 2x. So we will have du by dx equals to 4 and dv by dx equals to 2x minus 2. Then we will have dy by dx equals to v du by dx minus u dv by dx over v squared. So by putting all this thing in, we will have x squared minus 2x times 4 minus 4x times 2x minus 2 over v squared. Okay, let me scroll down a bit. Then we can just expand and simplify this. Then we have 4x squared minus 8x minus 8x squared plus 8x. And as for the denominator, you can choose not to expand it. So we will just put in this form. So we simplify the numerator, we will have negative 4x squared. 4x squared minus 8x squared, we have negative 4x squared. And negative 8x plus 8x is gone. And we will have x squared. So for these equations, students, remember, whenever you see an equations where you see x involved in both numerator and denominator quotients, and you cannot separate this into a few terms, quotient rule is the only way. So that's all for today. If you like my contents, please comment, like, and subscribe.